Hey everybody, welcome to a new video. In this video we are going to see how to translate again a ShaderToy shader to Max, and this time we are going to go for something a bit more complex. So we are going to translate this shader here, which as you can see, is kind of a thermal particles fluid simulation. And as you can see, it's pretty cool. It uses the buffer method that you have in ShaderToy to achieve this effect, because you have kind of to track the position of the particles from buffer to buffer, do several times on a single frame the same calculations, and in the end output an image based on these calculations. So basically what the shader does, it executes all this buffer in the same frame before going out through the image shader. So we are going to recreate the same shader in Max. So we are going to copy the code and rearrange it in a way that is readable and usable inside Max MSP Jitter. Okay, so well, let's start. Let's go into Jitter. So let's create the Max objects that we'll need. We will surely need a JIT world with a couple of attributes. For example, let's give it a name. I always call it game. Then let's give it an attribute for floating window, size of the window. And then let's give it FSAA. It's not really useful in this case because it works mostly with meshes, but let's use it anyway. Then we need I don't know. That's actually I think it. So window appears. Let's create a toggle to activate the JIT world object. Cool. Then what we need is let's create also a JIT FPS guy to monitor our frame per second. Then what we need to do is to create a GGL texture. This will be the initial input to our shader. So let's give it the attribute float type. This must be float32 because this shader here requires calculation. The calculation must be very precise, and by default, the type of the GGL texture, if we don't write anything, the type by default is auto, and we cannot be sure that it's not going to be float or float16 or even char. We have to set it to float32 because we want at least float16 calculations, but let's set it to float32. So not this, but I have to write float type float32. Okay, so the calculations inside the shader will be more precise because the shader is going to operate in float32 with float32 point data. Cool. Then let's create a jit.gl.slab. jit.gl.slab, let's give it the name of the contest and the name. So now we have to create the various buffers. So this is going to be buffer A. Okay. Good. And then we have to create another buffer and call it buff B. Then buff C. Whoops. Then buff C. And then let's create also buffer D. Cool. Okay. Then let's see buffer A. Which code does it have? So buffer A has this code. Let's copy it. Let's go inside our jit.slab default shader. Let's actually save it on the desktop. I will call this buff A shad.jxs. Cool. On the desktop. My patch resides on the desktop. So when I give it this guy the name, the file shad, how did I call it? So I called it buff a shad.jxs. Cool. And cool. So let's go inside our file and let's copy the code from the first shader, the first buffer shader here. Let's copy this code here. So boom. We replace the main function in the fragment shader. So here we are inside the fragment shader. We are inside here the fragment shader. Let's copy this function in and replace the main function here. Now, cool. First thing to do, you see that there is a void main image that in Max.gl.slab this is actually called not main image, but it's called just main. And then you see that it has some arguments. So out vector for q, this will be our output, and input vector to u, and this will be our input. Now the q, this will be our output color, and u will be our input coordinates for the shader. So basically we have to write these vectors ourselves because we cannot get arguments inside Max for this main function. We cannot get them, these arguments, so we have to declare them inside our shader. So this we saw it's a vector 4, and then let's set it to 0, and then we have u, which is equal to our text card varying variable that comes from the vertex shader, as you can see. Okay, this we set. Let's see what else do we need. Now there is a function here called t, which returns a texture reading of this texture iChannel 0, and then we have another texture called iChannel 1. So let's proceed to declare these textures. So we have to write uniform sampler to direct iChannel 0, and then uniform sample to direct iChannel 1. Okay, cool. Now we have declared these textures as uniform. Now to read them, we have to use the function texture to direct. So texture to direct. Cool. Then we have to declare these as parameters inside our parameter declaration and parameter binding. Let's set this to version 1.2 just because. And then let's actually delete this scale value, we don't need it. So let's delete the scale value. Let's delete it also here from the fragment shader. We don't need this guy. Let's delete also this because we already have this iChannel 0. So this we call iChannel 0. We've been to fragment shader, and this we call iChannel 0. We declare it. Cool. Let's copy this. And let's actually write iChannel 1. Default 1. Let's copy this because 0 will be our channel 0, our first texture, and our second texture. So the second input of jit.gl.slab will be our texture 1. So let's copy this here, iChannel 1, let's bind it also to the fragment shader, fragment program. So cool, so now we have the textures that we need, we have them. Cool, then what else do we need? High resolution. So high resolution is basically the dimensions of our texture. Cool, then let's do like this. Let's actually set the dimensions of our texture to be the same as our window here. So we can do something like this. We can create the get attribute object and get the attribute size from the jit world object. So bam, let's see what we get out of this guy. Okay, we got some errors from the shader. This is not a problem. Cool, so this we get the size of the window. Let's actually set the FPS for this bad boy to 120. So now we should be around 120. Cool. Okay, cool. Now let's use these numbers to set the dimensions of our texture here. Okay. And let's also say adapt 0 just to be sure that it doesn't change its dimensions automatically. So if we modify the size of the window now, this texture is going to have the same size of our JIT window. Okay, cool. Now, what we can do inside the shader here, we can declare a variable. So a uniform, let's call it window size. This is type back2. And this is a state variable, which means it comes directly from Max, and this is called viewport. And this is the size of our jitter window, directly inside our shader. So, pretty cool. So let's bind it. This is called window size program equals fp. Bam. Okay, cool. Now let's declare it inside the fragment shader. This is also a uniform. This is back to window size. Cool. Actually, let's call it high resolution so we don't have to change all the variables inside the shader. Okay, so let's replace this and let's replace this. Cool. Now we also have high resolution. Cool. Actually, we don't get any more error. Only thing we have to do is to assign the output of this shader, so gl_frag_color equal to q, because this was our output that was declared here. But we have actually to explicitly set it inside maxMSP to gl_frag_color in GLSL version 1.2. So cool. Now let's go back to ShaderToy. Now, as you can see, buffer A, B, and C, they all share the same code. Then buffer D and the image are different, but A, B, and C, they all share the same code. So they can all have the same file. So the same buffer, the same shader. I should have called it something different, not buffer A, because now this is a bit confusing. We still get some error actually. So let's see what we get. Undefined variable iMouse. Okay, so let's set also the mouse. So param name. These are all variables that you get automatically from ShaderToy, but we have to declare them all inside max, of course, because they don't come automatically. So iMouse is of type vec3 inside the shader. And let's set it to default to 0.0, 0.0, 0.0. This is how you set a vec3 default. And then let's bind it. So bind param iMouse program fp. Oh, and by the way, this trick with the viewport was suggested to me from, by Rob Ramirez. So thank you, Rob, for this tip. It's really cool. And okay, so what were we saying? iMouse. Okay, cool. Let's declare it inside here. So uniform vec3 iMouse. Okay, so now we're good with iMouse. We now need iframe. So param name iframe. This is basically how many frames passed since we start our program. This is an integer. Default is equal to 0. Cool. Let's bind it.
Bind param iframe program equal to fp. Bam, bam. Okay.
Super. Let's declare it also here. Uniform int iframe. Cool. So now we should really be good. If I assign it also to this slab here, so file buff a shad.jxs. Okay, cool, we don't get any error anymore. So let's now take a look at the ShaderToy here. Now you can see buffer A as an input as buffer C and buffer D. Buffer B as buffer A and buffer D, and buffer C as buffer B and buffer D. So buffer A as input C and D. Buffer B as input as A and D. And I think buffer C will have as input B and D. Let's see if this is correct. Exactly, B and D. Cool, so this as input is as buffer A, which is this slab here, and this as input as buffer D, which is this slab here. And buffer A has as input buffer C, but we cannot just attach this here. So we cannot just attach buffer D here, because this will cause a stack overflow. So what we have to do is to create another ggl_slab game automatic 0 and then also true 0. This means this will only pass the texture only when it receives a bang. So we can do something like this. So let's select all these guys, bring them a bit to the right. So this will only output the texture only when it receives a bang. So now we can connect it here and connect our metro to this slab. Let's send actually the metro from our jit world. And let's actually load bank this. And as you can see, everything works. We don't get at least any Stack Overflow. So let's create also a jit.gl video plane to visualize what is going on with these guys. Let's also create the iframe parameter, and this we can use simply a counter to that. So let's create a counter, and let's also create a receiver for the metro. So this will be kind of the frames passed every time we stop the jit world. Let's send at 0. Let's send actually reset iframe, and let's say select 0. So this we can put here, and whenever we stop the world, we will send at 0 to our iframe, which means we are restarting the frame counter on next clock. Okay, cool. And then let's attach these to all these 4 slabs. Yeah, also this buffer D. Okay, cool. And everything is kind of okay. We don't see anything already. Okay, now that I bang on the texture, the initial texture, we see a blue color. So we see a very nice blue color here. Let's actually, every time we modify the sides of these, the sides of our window, let's actually send also a bang to. Let's actually also send a bang to our initial texture. Okay, cool. Now let's go on with the shader code, and let's see what do we have at buffer D. So let's copy it. Let's create a new shader here. So I open our new jit.gl.slab called buffd. Then I save this guy and I call it shad. How did I call the others? Buff a shad. So this we're going to call buffd shad.jxs. And let me copy the fragment code inside the fragment program. And let's actually copy all the stuff that we already wrote inside. So all the parameters we already wrote inside our buffer A code. I will just copy them here. So let's replace all this stuff. Okay, good. Now, what do we have here? Exactly, let's also copy all the uniforms that we set for the previous shader code. Okay, cool. Okay, let's see what we have here then. So we have again main image, which we have to call main with the same output and input, which we have actually to substitute with void. Then this is an undeclared variable. Let's declare it. I don't know how if you can get away with it in ShaderToy, but in Max we have to declare it. So let's declare here a vec4, which is equal q, which will be our color output, which is at the moment equal to u. So we have also to declare u, which, as we saw, it's going to be our texture coordinate. Okay, cool. And blah blah blah. This we don't care about. Okay, cool. So it seems that everything is cool here. In the end, we just have to write frag color equal to q. GL frag color equal to q. One thing that we have to do is to also replace this into texture to direct. Because this is the function that we have inside GLSL in Max. And as you can see, this divides the coordinates by r, which is our resolution. So basically normalize the coordinate in 0 to 1. Now, since this is a texture 2D rectangle, this means that it doesn't take normalized coordinates, but it takes actually the actual fragment coordinates to read the texture. So we don't have to divide this through air. We also have to do the same thing inside this code. I think I forgot it. Yes. So we have to delete this division by air, because texture to direct is a rectangle texture. And go on my website and see the tutorial that I did about reading texture in GLSL to see what this actually means. Okay, cool. Then I close this. And let's see. So all these guys get their input from the buffer D, as we can see here. Actually, I made a mistake. This goes here because this takes the first input must be C. So this is just a texture that we give in the beginning to start, kind of to start the word calculation, but the second input will be our buffer D. Now let's see what is actually the input of buffer D. As you can see here is the channel A, and it takes also channel D as an input, so it takes itself as an input. Okay, so it takes channel A, buffer A, which is this one, and its output actually goes to all these guys. But let's create another one of these jit.gl.slab. Let's create a trig bang bang here, and let's do like this. So first go to this guy, then go to this guy. Okay, so this must go here, and that must go here, here, and here, and it also has to go to itself. So boom. Okay. So this is what he has to do. Let's see if we get something interesting on the output. We get some strange stuff on the output here, but kind of interesting also. Kind of interesting, strange stuff. Let's create our last... Oh, let me actually write the file here. Let me actually write the file, because otherwise it doesn't work. So file, it will be equal to buff.the.shad.jxs. Okay. And this is our code exactly. Okay, cool. So we get some strange stuff going on, but let's see if this works by creating the last. So this as input takes A and also D. Let's create our last code, which is image. So let's copy it. Let's create another jit.gl.slab. Let's call it image. And let's give it as a default, as a file. Let's give it actually buff.the.shad.jxs, because we are going to save this as save as, and let's call it actually image.jxs, actually shad image.jxs. Cool. And so we don't have to copy all the time the same stuff. And let's actually rename the file into shad image.jxs. Okay, cool. So let's replace all this code here until here with our code from the last ShaderToy code. So we have to replace this into main. These guys get replaced with void. Let's declare this as a back2, this is a back4, okay. And let's output, so gl frag color equal to C. Okay. So what does it take as an input? It takes from buffer A and also a cube map. How do I know that this is a cube map? Because if you go in cube map, you can see that this is actually a cube map. So let's go back to our file. Let's go back to our file and let's attach this to buffer A, because this is what it takes as an output. And as we can see, we get some error. But we also get something starting to draw on our window. Okay, what is going on? Undefined variable u. Okay, undefined variable u. Of course, I didn't declare u, nor I didn't declare q. So let's create them both. First q. Back for 0.0, back to u equal to text chord, as we did in the other shaders. And what do we get? Undefined variable c. Because actually we don't have q here, we have c. Okay. So Now, we also have to delete this divided by r, because as we saw, and we start to get it. We start to get it. Cool. We basically got it. The only thing we have to do is to read the cube map. Now, to declare this texture as a cube map, we have to write sampler cube, iChannel 1. Cool, and it's basically already it. It's basically already it, but texture, we have to replace it with texture cube. Now, there is no texture cube attached, so we could, for example, create a jit.gl cube map, game, and then we can go on the help file and see, get this read. So we read this cube map that comes already with Max. Let's create a load bang. Cool. Let's attach this here. And let's also output it. So I don't know if this makes this crazy difference, but this is how you read a cube map. Cool. And oh, I got full screen, and so what we have to do every time we go full screen, for example, is to actually set again the frame to 0. Reset the frame counter to 0. So what we can do is to... So let's create another get at, and let's call it full screen. Let's get the attribute full screen. And let's see what we get out of this. I go in and outside of full screen. Okay, cool. So select one. Actually, it doesn't matter. Every time we do something, let's just trigger bang to reset the counter. So let's see if this works. Not really. Let's maybe set a small delay. So the frame will be reset. Okay, cool. Yeah. I'm not sure it actually took the new dimensions of the window, so it should. Let's set also a delay for that. 100 milliseconds also for this bang here. In order that it gets the right dimensions of the window. Okay, cool. And now I got it. Cool. We managed. So what it seemed like a really complex shader was actually a kitty catty, and we tamed it. So enjoy your new power. You can actually now convert every shader toy that you find on ShaderToy. Every ShaderToy shader that you find on ShaderToy. Have fun. If you have problems, just write me under the comments. Write me on my Facebook page. I will try to answer you for real. And if you want, you can support me on Patreon. This will be much appreciated. I will leave the link in the description. In the meanwhile, take care, people, and see you in the next video. Ciao.